Alright, you're wildly biking through traffic and everybody's honking at you, somebody directly behind you and somebody directly in front of you. And it sounds like both of those notes are at the same frequency, but they're not because you're moving, the doppler effect is happening. So if we know somehow that the Chevy Bolt actually honks with an F4 note, and that's not like fourth harmonic, that's F as in not a G or an A or a B or a C note. That's actually a middle F, and that's 349 hertz. So if we know that, what is the actual frequency of the car in front of us honking at? Okay, so here's what we know. The perceived sound, and this little prime mark means this is what we hear. The perceived sound of the Ford is the same frequency as the perceived frequency from the Chevy Bolt. And since we have equations that describe the Doppler effect, we can define these frequencies in terms of the frequency we hear. We are moving toward the Ford in front of us. So that's different than if the Ford was moving at us. Since we, the listener, are moving, we use the second equation on the PowerPoint slide, which is this. So the frequency that we hear from the Ford is the actual frequency of the Ford multiplied by this term. And here this is the velocity of us, the observer, the velocity of us on our bike, which is 10.7 meters per second. And this is the speed of sound, which depending on the air temperature and pressure and everything today, could be somewhere around 340 meters per second. Let's say that we know that it's exactly 337 meters per second today. And that is equal to the perceived sound of the Bolt's horn. And we can do the same kind of thing here, except here's the tricky part. We are moving away from the Chevy Bolt. So if our velocity was positive moving toward the Ford, it's going to be negative moving away from the Bolt. So to get f prime b, we take this term multiplied by the actual frequency of the Bolt's horn, which we know is actually 349 hertz. So let's take this equation that we've put together and start manipulating it and putting in numbers that we know, which gives us that. And there's our next step. And that's what frequency the horn's actually honking at. And this is lower than what you're hearing. And that makes sense because you're driving toward it, and you're biking toward it. And when things come together, the Doppler shift of the frequency is for it to get higher. So it will sound higher to you than it actually is.